Students, I'll be starting the class in next 5 minutes. Okay, keep revising the topics of yesterday. I'm going to randomly call and ask. So have all the definitions, okay, formulae, everything revised. Okay.
Yeah. So you're able to hear me?
Sir. Yes, sir.
Okay. So listen, first we'll start with Hariharan.
Sir,
Yeah. So state the Newton's law of gravitation.
is the law that says that every body in the universe attracts other bodies, sir?
That's one. That's the one. Yeah. State it completely. What are the mathematical relation and everything?
Every body in the universe attracts every other body. Uh, ah, Everybody in the universe attracts every other body with a force that is directly proportional to the product of their masses, sir. and also
Product of-
inversely proportional to the square of the distance between them, sir.
Yes. So that's right. So give me the mathematical expression. F is equal to,
F
we
is
solved
equal
many
to
problems. Hmm.
gravitational constant into the product of masses. This m1 into m2
Mhm.
by the distance, sir. So distance square, sir.
By distance square. Okay.
E is equal
So
to
what is
6
that? Okay. Okay. Yeah. Okay. Wait. Hari Raghav.
Sir?
What is the value of capital G?
So 6.67 into 10 to the power minus 7.
Units.
Newton meter.
Newton.
Newton meter, kg minus 2.
Newton. Rearrange and see, no?
Sorry, sir.
Hmm.
So it's Newton meter square, kg minus 2.
Newton meter square per kilogram square.
Kg square, sir. Yes.
Yes. Okay. What is going to be the dimensional formula of it? What is the dimensional formula? M.
Sir, it's m minus 1,
Hmm.
L 1 also.
Hmm.
So it's m minus 1, L3,
T.
T minus 2.
Okay. Srinidhi.
Yes, sir.
Hmm. Tell me Newton's law of gravitation in vector form. F is equal to F vector is equal to, how
Sir,
do you write?
F vector is equal to R1 vector plus R2 vector.
That's not the vector form. That's not the vector form. Check your notes. What is written? Did you attend yesterday's class?
Yes, sir. 1 minute, sir.
I would have told you F12 vector is equal to
Yes,
GM1.
sir. Minus GM1 M2 by R2 vector minus R1 vector, the whole cube, R2 vector minus R1 vector.
Mhm. That's not how I taught. I don't know where you're seeing it. I taught it in the way F12 vector. I never used minus sign at all. So F12 vector is equal to minus G M1 M2 divided by R square into R21 cap. Right? Check your notes. Shri Kriti,
Sir,
you tell me. What is F21 vector is equal to?
G M1 M2 by R square into R12 cap.
Correct. Okay. So tell me principle of superposition also.
Sir, like on a single particle of mass, many masses are there, forces are acting, then the resultant force will be the vector sum of those two forces experienced by the particle.
Okay. So wait a minute. Gravity. Okay. See, suppose there are particles like this M1, M2, and M3 present in the system. Okay. M1 is there. So what are the force experienced by M1 due to M2 and M3? What is the answer for it? Shri Kriti, what is the answer for this? How do you write the mathematical expression? I'm not concerned about what is the final answer that you cannot get because they didn't give you the distance.
1 second, sir.
You tell me, I'll write. You need not do it in your book. You tell me how I should write.
Sir, M31, like M21 will pull the mass M1 with a force F12
In which direction?
towards M2,
Very good. This is
F12.
So this is going to be F12 vector. Okay.
And
Similarly,
M3 will pull the mass M1 with the force F13.
okay. F12 vector plus F13 vector will be equal to what?
A resultant force vector
Experienced by
M1,
due to M2 and
M3.
M3. Am I right? That's
Yes,
correct.
sir.
Yeah. Catherine,
Yes, sir.
so yesterday we saw another concept of acceleration due to gravity.
Sir.
Yeah. So when we saw the acceleration due to gravity, what were the 3 points at which we calculated the values?
Sir, I was absent yesterday, sir.
Were not there.
No, sir. I'll get the notes from Shri Kriti, sir.
Mhm. One minute. Harini,
Yes, sir.
yeah. So when we calculated the acceleration due to gravity, we calculated 3 points, right? What are the 3 points at which we calculated? One is at the surface. Next,
Sir, I'm not sure.
you didn't attend yesterday's class.
Sir, I attended it, but I had internet issues.
Okay. Murli,
Sir,
tell me, what are the 3 points?
yes, sir. So one was on surface of the earth, the other was acceleration due to gravity at height h, and then acceleration due to gravity at depth t.
Height h at
Depth t,
depth
sir.
t, right? So on
Yes,
the
sir.
surface, right? If I want to calculate on the surface, if I consider this to be the earth, if this is the object of mass m, and if I consider this to be the center of the earth, right? And if I take this to be the radius of the earth, and at the center of the earth, the mass of the earth is said to be concentrated, right? So for me to calculate the acceleration due to gravity at the surface, what is the mathematical equation I'm supposed to write?
Sir, small g is equal to capital G me by r square. Sir.
That we got it as a end result of the derivation. But what is the first step with which I need to start with?
Mg is equal to gmm by r square.
So mg is equal to g
Small m
Small
capital
m.
M by r square.
capital Me divided by Re square. Me stands for the mass of the earth, Re stands for the radius of the earth. Now tell me, what does this mg mean? Mg is the,
So weight of the object.
very good, it's the weight of the object. And what about this one? It is the gravitational pull experienced by whom?
By the
By
object.
right? So what will
Yes.
happen? M and M will get cancelled. So small g will be equal to capital G into Me divided by Re square. Right. So when you take the value of capital G, how much is it? 6.67 into 10 power
10 power minus 11, sir.
minus 11. It is in the SI unit. What about the mass of the earth?
1 second.
6 into 10 power 24 kilogram. What is the radius of the earth?
6,300 kilometers.
That is 6.4 into 10 power
10 power.
4. I'm sorry. 6.4 into 10 power 3 meter. You substitute all these values. What is the value of small g that we are going to get?
9.8 meter per second square, sir.
That's right. Good. Now you answer this also. At height h. Okay. Okay. You come. I'll ask you again. As of now, you go on mute. Divya.
Sir,
So how do I frame the equation for this one? At height h, if I consider this to be the earth, surface of the earth, the object is at a height h, right? And the radius is r, right? So how do I frame the equation? Tell me. No or not? You know the answer or not?
Sir, I don't know, sir.
You wrote in your notes? You took the notes yesterday?
Sir, partially I took, sir. Half I took and half I didn't.
Shri Kriti,
sir,
tell me, how do I frame the equation?
sir, F is equal,
No.
mg dash is equal to g small m capital M divided by r plus h whole square.
Very good. So what will get cancelled?
M and small m.
Okay. So G dash will be equal to how much?
Gm by
Hmm.
r plus h whole square.
Okay. So is there anything I can do with this?
You should take r square common out.
You should take R common. When you take R common, you will get R square into 1 plus H by R whole square. So what is Gm divided by R square?
Small g.
So small g divided by 1 plus H by R the whole square. This is one of the formulae. And when will you use it? When will you use this equation? When the value of h is comparable to the value of r, right? So g dash will be equal to g into, can I write it as 1 plus h by r the whole power minus 2?
Yes, sir.
So if h is very much less than r, then what will the value of g dash be equal to?
1 minus 2h by r. Oh, g into 1 minus 2h by r.
Why did we get this, or how did we get this?
Binomial theorem.
Yes, 1 plus x the whole power n is equal to
1 plus nx if x is far very less than 1.
if mod x is very much less than 1. Right? Correct. So Murli again.
Sir,
So if I want to find it at depth d,
yes, sir.
what should I do? What are the
mg double dash is equal
First,
to
what is the difference between the other two and this one?
which one, sir?
In the other two derivations, we directly wrote mg is equal to something. Here we can't write mg is equal to g small m into capital M by r square. Why? Because the whole mass of the earth is not going to participate when the object is at a depth d.
Okay, sir.
Yeah, 1 minute. One minute. Okay. So when the object is at depth d, right, then what is going to be the radius here? It is going to be r minus d.
Yes, sir.
Correct. So what would be the equivalent mass that will actually act on the small mass to pull it towards its center? What will be the value of m dash e? M dash will be equal to m into, or how do I even find it out? First, what did we define? Check your notes and tell me.
Yes, sir. I'm looking, sir.
So first I would have defined density. Density of the earth
Yes,
is
sir.
equal to mass by total volume.
Yes,
Those
sir.
who have not, 1 minute, those who have not learned it clearly, at least now pay attention and take down notes. Okay. So rho is equal to m divided by 4 by 3 pi r cube. The same rho will be equal to, can I say m dash divided by 4 by 3 into pi into r minus d the whole cube?
Yes, sir.
Then what will m dash be equal to? M dash will be equal to m into r minus d the whole cube divided by r cube. So let this be equation number 1. Right. Now, once I get this, what should I write? M into g double dash will be equal to g into small m into capital M dash divided by r minus d the whole square. Correct, Adada?
Yes, sir.
Why? I feel there is a mistake in this equation. Check.
No, sir. This is what I copied.
It's correct. Okay. So m and m will get cancelled. So g double dash will be equal to g by r minus d the whole square into m dash is m into r minus d the whole cube divided by r cube. Now what should I do now?
So
Cancel. What should I do?
So r minus t whole square and the cube, sir.
Right. Then what should I
Yes.
do to this r cube?
R
R square into r minus d divided by r. So what is the gm divided by r square? It is small g
G.
in
Yes, sir.
1 minus d divided by r. Right? Did we solve problem based on this yesterday? I don't think so.
No,
We
sir.
did only problem based on
Think surface and height, sir.
surface and altitude. Right? We didn't do problem based on. Okay. So with this, see, actually 95% of the chapter is over yesterday itself. Okay. Next. There is another concept called Kepler's law, but Kepler's law is deleted, so not needed. I'm not teaching that part. I'm searching what was the last problem we did. Okay. I'm going to share my screen. See this. Look at the 21st problem. Are you able to see my screen?
Yes, sir.
1 minute. I'm not able to see. Yeah. So you're able to see the 21st problem.
Sir,
So how to do this? How much below the surface of the earth? So when they say below the surface, they're talking about depth. How much below the surface of the earth does the acceleration due to gravity become 1% of its value at the earth's surface? So how to solve this? So what is how do we proceed? Tell me. So how much below the surface of the earth means what should we use? G double dash is equal to G into 1 minus D divided by R. Right. So what should I write the value as? G double dash is equal to G minus G into D divided by R. Am I right? So I'll take G double dash to the right and GD by R to the left. So GD divided by R is equal to G minus G double dash, which implies G minus G double dash divided by G is equal to D divided by R. So what is this value? This value is the fractional change. So multiply this with 100 on both the sides. So G double dash minus G divided by G into 100 is equal to D divided by R into 100. How much is this supposed to be? 1%. So which implies D divided by R is equal to 1 by 100. So what will be the value of D? D will be equal to R divided by 100. R is how much? 6,400 divided by 100. Answer will be 64. Okay. So if you go 64 meter, 64 kilometer below the surface of the earth, sorry. Yeah, 64 kilometer below the surface of the earth, you'll be getting this. It'll decrease by 1%. Okay, look at the next one. At what height above the earth's surface the value of G is same as in a mine 80 kilometer deep? So there is an object which is at a height h, and the same object is kept at a depth of 80 kilometer, right? So GH is equal to GD. When is this possible? So what is the value of GH? G into 1 minus 2H divided by R, right, will be equal to GD is G into 1 minus D by R. So G and G will get cancelled. 1 is also lost. So we will have 2H by R is equal to D divided by R. R and R will get cancelled. So H is equal to D by 2, which will be 40 kilometers. So 40 kilometers above the surface of the earth will have the same acceleration due to gravity as that of the object which is placed 80 kilometers below the surface of the earth. Got it? Okay. We'll see the last two concepts of this chapter. Let me once check if Kepler's law is deleted. No, I'm sorry. Kepler's law is there. It's my mistake. Then we have some more points to be completed. So write down the next heading as gravitational potential energy. So the next topic that we are going to see is gravitational potential energy. Okay, let's observe what it is. So we have already heard this term gravitational potential energy of an object, right? So when two objects are placed close to one another, we know that they interact through the gravitational force, right? So because there is a force existing, what will happen is there will also be a potential energy possessed by the system, because for that kind of a system to be formed, you need to move the object from infinity to a particular point and keep them. Right. So the gravitational potential energy of an object is basically the energy possessed, right, with it due to its position in the gravitational field of another object, and is measured by the amount of work done. I've already told you, whenever you need to calculate potential energy, we are going to calculate the amount of work done in bringing an object from infinity to a point in the gravitational field of the other. So first, let me discuss this point. Suppose, visualize it. If I have 2 point masses M1 and M2, which are separated by a certain distance. So surrounding M1, can I say that there is going to be a region like this? So there is going to be a region where in that region, if you place M2, it starts experiencing force. Right? The region in which the object starts experiencing force is what is called as the gravitational field. So gravitational field is basically that region in which the gravitational field is that region in which the force is experienced by another mass that is placed. Right? Now, having said this, what we can say is there is a field due to M1 and M2 is experiencing force in it. Are you able to visualize it? Are you able to visualize this concept? So there are two masses, M1 and M2. Surrounding M1, there is a region. And in that region, if you place another mass, the second mass will start experiencing the force. So the region around the first mass where the second mass is experiencing force is what is called as the gravitational field. Am I clear with this concept? Right. Now see, when one object lies at infinity from another object. So when I say infinity means they are separated by a greater distance such that there is going to be no interaction between them. Infinity literally doesn't mean they are in different planets. No. They are separated by distance where one cannot influence the other. That's what is called as infinity. So the gravitational force on it is going to be zero. Consequently, what can you say? You can say that the potential energy is also going to be zero. That is why whenever an object is placed at infinity, it is said to possess zero potential energy. Please make a note of this point. Potential energy of an object at infinity is going to be zero. Is the point clear? Yes or no?
Yes, sir.
Now, the next job of ours is derive an expression for the gravitational potential energy of an object of mass m located at a distance r from the center of the earth, where that small r is actually greater than capital R. So listen to this carefully. I have the earth present here. Right? There is an object of mass m which is placed at a distance smaller from the center of the earth. And this is the radius. Right. So now what has happened is this mass was initially at infinity, meaning it was having no influence of the Earth's gravitational pull on it. So it was at infinity. From infinity, now it is brought to a distance smaller and it is placed. Now, when this is going to be the scenario, you listen to this carefully. The gravitational potential energy, can I define it as the amount of work done by an external force to bring an object from infinity to a point within the gravitational field? Right? So here, actually, you can change it like this one. Work done by the gravitational force itself. Because it's an attractive force, no? Work done by the gravitational force to bring an object from infinity to a point within the gravitational field is what is going to get stored in the form of gravitational potential energy. So, what is the force exerted by Earth on the mass? So F will be equal to G capital M into small m divided by x square. Am I right? Now let's say this object is displaced through a small value dx. So what I'm saying is this force has displaced small m through a distance dx. Right. Then what will happen is the small amount of work done will be equal to F into dx. Small amount of work done will be equal to F into dx. So integrating on both the sides, here initially the object was at infinity, now it is brought to a point R. So work done will be equal to integral of G capital M into small m divided by x square into dx, where the object is moved from infinity to R. When this has happened, this will be equal to G capital M into small m into integral of dx divided by x square from infinity to R. So G capital M into small m into integral of 1 by x square is going to be minus 1 by x from infinity to R, or this is going to be minus G small m into capital M divided by small r plus 0. The reason why I'm writing 0 is because when you substitute infinity in the place of x in the denominator, it will be a 0. So answer will be minus G capital M into small m divided by R. And this value is going to be the value of U, which is also called as gravitational potential energy.
Sir, can you once show the previous slide?
Yeah.
Okay, sir.
Okay. So I hope everybody made a note of this. Right? The next concept that we are going to see is, 1 minute. So the next concept is, write it down. It's called escape velocity. So the next concept is called as escape velocity, or it is called as VE. Suppose an object from here is thrown with a velocity V. Okay, if it is given a tangential velocity, what will happen is it will go travel and fall on the surface of the earth at some other point. So if I increase its velocity, it will take a bigger curvature and go and hit the surface at some other point. Whereas if I give it a velocity V sufficient enough so that it is not able to be pulled back by the earth itself, then this velocity means if it is able to escape the gravitational pull of the earth, then we call that velocity as the escape velocity. Yeah. So write down the definition for it. Minimum velocity with which an object should be projected Okay. So I'll give you another explanation to this. Listen. 1 minute. See, suppose this is the earth, right? If you are giving it velocity in such a way that it is able to escape the gravitational pull, right? So can I say, if I give it a minimum velocity when projected in upward direction, so minimum velocity when projected in upward direction, with which object can escape the gravitational pull of the planet, or I'll call it as gravitational pull of the earth, is called escape velocity. Can I say this? Right. Now, if you see, for obtaining escape velocity, concept is very simple. You're projecting it upwards. So initially, the object had only electrostatic potential energy on the surface of the earth. So it had the gravitational potential energy, which was converted to kinetic energy. So if you write U is equal to KE, then you will be able to obtain the escape velocity. So what is U? Minus G capital M into small m divided by RE is equal to, what is going to be the kinetic energy? It is going to be half M VE square. So M and M will get cancelled. And here one correction. Since I'm applying energy conservation, I should not put the minus sign. Okay. So M and M is there. So what will happen to the value of VE? I'll write it here itself. So VE square will be equal to GM divided by RE. So what will be the value of VE? Root of GM divided by RE. Now what I will do is, I'll multiply with RE and divide it with RE so that I'll get root of GM into RE divided by RE square. So what is GM divided by RE square? It is small g. So small g into RE is going to be equal to square root of this value. Sorry, square root of g into RE is what is going to be the escape velocity. Clear with this?
Sir, how did you equate the gravitational potential energy with the kinetic energy, sir?
Because the sum of both values will be okay. Sum of both values is what is going to be equal. Okay, I'll explain it again. Listen. When the object is here, right? When the object is here, it is given a velocity VE. Am I right? So if you take this to be the surface, the horizontal line, now this is R. So what are the total energy possessed by the object here?
Potential energy, sir.
It is actually, did I say only potential energy?
Gravitational potential energy.
The gravitational potential energy, is that what I told? But you are able to see something else also, no?
Velocity, sir.
So what will be there?
Kinetic energy.
So I'm just explaining another way. So total energy at point A will be equal to, when I say the object is given escape velocity, where is it going to? It is traveling to infinity. Right? So at infinity, you have no data related to the kinetic energy, but gravitational potential energy is going to be 0. So the total energy at point A should be equal to the total energy at infinity, which is going to be a 0. Okay. So gravitational potential energy plus kinetic energy should be equal to 0. If I write it like this, then the gravitational potential energy, I can take it as minus GMM divided by RE plus, what is the kinetic energy? Half mVE square will be equal to 0. Take it to the other side, the equation will get balanced.
Yes, sir.
Sir, then what is MGH? That is also gravitational potential energy, right?
That is also gravitational potential energy. That is, mgh is a value which is taken closer to the surface of the earth.
Sir, but in that, when object is on the surface of the earth, the potential energy would be 0, right? Because the reference line and the object coincides. But here, when it is at earth only, the potential energy is maximum.
I didn't say it is maximum. And actually, you have a negative value, right? Okay, you're saying this value is maximum. Is that what you're thinking?
Yes, sir.
It is maximum the negative side. Okay. Your doubt is, at a height h, how am I able to take it as mgh? Is this what you're asking?
Yes, sir.
So you think and tell me, how will you use this relation to get that value?
So then it should be RE plus H, sir, that distance.
That's correct. So here if you see, what is going to be the gravitational potential energy at point A? So absolute potential at point A is going to be equal to minus
Minus G capital M small m by R.
what about the potential energy at B? Minus G into capital M into small m divided by R plus H. Is that right? So if you calculate the
sir.
potential energy difference, how much are you going to get? Is what the question is. So yeah. So what is going to be UB minus UA? Going to be minus GM divided M into M divided by R plus H minus of minus GMM into M divided by R. Is that right? So
Yes, sir.
can I take that GMM outside into 1 by R minus 1 by R plus H? Can I do it like this?
Yes, sir.
So GMM into, listen to this carefully, R plus H minus R divided by R into R plus H. Am I right? So R and R will get cancelled. So can I write that GMM divided by, if I take this R outside and multiply it with the R which is outside, so what will I get? I'll get R square into 1 plus H by R. What did I miss in the numerator? Small h.
Yes, sir.
Right. Now see, what is the GM divided by R square?
Small g.
Into M into H is also there. And can I write this as 1 plus H by R to the power of minus 1?
Yes, sir.
Okay. Now if you see, this will actually be mgh into 1 minus H divided by R. But what did I tell you? The formula of mgh can be used. When can it be used? When the value of H is very much less than R. Is it right? When the value of H
Yes,
is very much less than R, H by R can actually be approximated to 0. When I approximate it to 0, this value is lost. So this will give you mgh. That is how it is obtained using this equation. So what you have learned there is actually the potential energy difference concept according to this one. So what did I do? I didn't calculate the absolute potentials. I calculated the potential energy difference. Is it clear?
Yes, sir.
So try to understand. I'll answer your question. Listen to this. So when we discussed the concept of gravitational potential energy in the case of work, power, and energy chapter, there what did we say? The energy possessed by the object by virtue of its position. Okay, potential energy is energy possessed by the object by virtue of its position. But what when you want to calculate the energy, what did I tell you? Always calculate the work done. So there, what did we do? It was the amount of work done by the gravitational force when the object has traveled a distance of h units. So in that context, I understand where you're coming from. In that context, if you see, since we wanted to measure the relative displacement, observe the same logic is what I have considered here also. See, if you look at this diagram, if the object has moved from A to B, this distance is h. Okay. So with respect to the center of the earth, if you take into consideration, can I call this as R plus H? And can I call this as R? Shrikriti, are you able to understand this point?
Yes, sir.
Now, if you take, what is the relative displacement that has caused on the object? It is still H. That is why here I calculated the gravitational potential energies with respect to whom? With respect to the center of the earth, and I calculate the potential difference, potential energy difference between points A and B. Pridham. Whereas if you want to directly apply MGH, what you will do is you will take that reference point to have zero potential energy. That is why they both are actually giving you the same value. Provided you can use MGH only when the object is closer to the surface of Earth. That is why when you see the problem based on work energy power, the displacement of the object in vertical direction will be in terms of few meter. It will not be in terms of kilometer and all. Because you'll be throwing a ball or something of that sort. Right? So generally those objects travel only to a distance of few meters. That is why we could use this for. Am I clear? Did I answer your question? Or is there anything else you have in your mind?
Yes, sir, I got cleared.
Got the answer? So just to simplify, right? Again, coming back to the concept of escape velocity, the derivation is only 2 steps. What are we supposed to do? Equate the potential energy to the kinetic energy and rearrange the equation. VE will be equal to root of Gm divided by Re square into Re, multiply and divide with Re. So it will be equal to small g into Re. Okay. Now, there is another concept called as orbital velocity. So as the name suggests, orbital means if you need to put the object in a particular orbit. So I discussed one concept, no? If you give velocity to the object, right? It will go and hit the surface here, right? If you give a minimum velocity to the object in such a way that if this object is going to travel in a concentric circle around the earth itself, if it is going to travel in a concentric circle around the earth, then that minimum velocity is called as the orbital velocity. So what is it? It is the minimum tangential velocity to be given to the particle for it to move in a circular orbit is what is called as orbital velocity. Okay. Now what will happen is, for orbital velocity, what we can state is centripetal force should be equal to the gravitational force. So what is the centripetal force here? It is m v naught square divided by r should be equal to, right, mv naught square divided by r should be equal to G capital M into small m divided by r square. So r and r will get cancelled, which implies one minute. Here, guys, even you didn't tell me. Here I missed it too. So the escape velocity is actually square root of 2 times G into Re. I missed this too. So root of 2 times G into Re is what is going to be the escape velocity. Okay. So please make the change. Okay. Now, if you see here, what will happen? V naught will be equal to square root of G into capital M divided by R square. So this will be equal to root of G, sorry, not R square, it is R. And I need to multiply with R to get that R square. So it will be square root of the GM divided by R square is small g into capital R. So if you observe, orbital velocity is root 2 times less than the escape velocity. Are you clear with this? Is there any doubt? Is there anyone having doubt of why the centripetal force is equal to the gravitational force?
Sir, can you
Yes.
explain the surface?
Which one? That point, huh?
Yes.
See, listen. If an object is supposed to be in a circular path, then what force is needed? If it has a tangential velocity of V naught, what is the force that is going to act towards the center? It's the centripetal force, which is given by the value mv naught square divided by r. And that centripetal force is provided by whom? It is provided by the gravitational force acting between the planet and the object which is revolving in that orbit. So now you cancel it. Did you understand what I did?
Yes, sir.
Right? So this V naught will be equal to root of Gm divided by R into multiply with R and divided with R. So you will get a root of G into R. Clear? Okay. So with this, as I mentioned, 95% of the chapter is over. One concept that is left out is Kepler's planetary laws of motion. About that, we'll discuss it in the next class. Okay. Yeah. So revise all these concepts and be ready. Next class, what I'll do is first half an hour, I'll be completing the Kepler's laws. Then I'll be starting elasticity. So going forward, except 11th chapter, not 11th, except 10th chapter, that is fluid mechanics. Every other chapter will maximum get completed in 1 or 2 classes. Or maximum 3 classes. Okay. So start preparing accordingly and follow the schedule strictly. Is it clear? Is there any other doubt? Can I assume everything is clear?
Yes, sir.
Perfect. Then we'll wind up for today. We'll see you in the next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.